Hello and welcome to the Product Science Live demo, where today we will learn together about the solutions that Product Science offers to make your mobile apps faster. So before we start the demo, a few words about myself. My name is Anastasia Matveyeva. I'm the lead product scientist working with PS Tool for the past 2 years. All this time, I've been solving performance problems alongside with our clients and optimizing mobile apps of all sizes and complexities across different industries, both for iOS and Android. My background is in research in mathematics, so being somewhat technical, yet I've never worked as a mobile engineer myself, which did not stop me from finding actionable optimization opportunities. And all of it is thanks to PS Tool, the great visibility that it provides into the code and how it is executed, as well as accessibility and intuitiveness of the tool. And that is exactly what I would like to share with you today. Now, today's demo will be showcasing Android example, while PS Tool actually offers the same functionality for the iOS. So in case you're interested in iOS specifically, stay tuned for the rest of the series of these live demos, as well as don't hesitate to contact with us on LinkedIn, send us an email, schedule another demo. Just let's connect. So again, before diving into the technical part of the demo, let's make sure that you all came to the right place. And if you're a mobile engineer yourself facing some performance issues, then resolving them can be a challenge. And there are different reasons for that. One of them is that performance work tends to be isolated from the rest of product development. Most of the tools that are available on the market are designed to notify you about the delays, but not to pinpoint the root cause of them. And it often requires a lot of attention and a lot of tedious work to find the core issue and backtrack it to the root cause. It also often involves diving into the legacy code from multiple different teams. Manually instrumenting this code can be a lot of pain, while maintaining this instrumentation as the code changes is also a continuous effort. So performance optimization, performance work is like hard on its own, but not only for engineers. And if you're a product manager or any other stakeholder who is not necessarily technical, you would still see and recognize performance issues. As a user of the app, you will notice scenarios in which it works slowly, but communicating it with your engineering team communicating on those issues can be hard because, well, there are multiple reasons, but one of them is that a lot of existing observability tools often track something that they detect degradation, but they would track something that's not obviously related to the root cause or even sometimes to the user experience. For example, loading time may not be the same as the time that user spends waiting for the content. And if those metrics are not very transparent, it can be also very challenging to formulate what needs to be done, as well as prioritize such tasks and measure their impact on user experience and eventually the metrics that you're interested in, like user retention. And as mentioned in the beginning, PS Tool provides a very intuitive way that can relate both how your code was executing while also showing you what was visible on the screen to a real user at the same time. So if you recognized yourself on this slide, stay tuned. Now, a few words about traditional performance optimization, and this process requires a lot of research. Normally, you would have to spend days manually instrumenting your code, collecting the data on the way how it is executed via multiple different tools, and spend hours making the sense out of it, testing your hypothesis. And if it didn't work, you'll have to do it all from scratch. Now, among this work, instrumentation is a particular challenge on its own. So if you're manually instrumenting your code, it can take days to mark up everything that you need to understand the behavior of your code. Even if you have done it once, maintaining instrumentation is a separate task that needs to be done every time the code is updated. Automatically instrumenting all your code will not solve the problem immediately because recording everything executed in your code would introduce a significant performance overhead. The picture that you will obtain will contain a lot of noise from the meaningless methods executing in your code thousands of times, yet not impacting the performance directly. And it is extremely hard to make sense out of this combination and to work with it. So first part of the PS2 unique features solves the instrumentation challenge. Product Science plugin automatically instruments your code, as well as all the third-party libraries that your app is using. And then our AI-based filtering makes sure to record all of these events, only those that matter for performance and that eventually affects the user experience. So at this point, you might have a question like, but how does your tool understand what matters for the user experience? And by the end of this presentation, by the end of this demo, I hope you'll get a really good sense on how this question can be answered and how to actually make sure which methods impact user experience and impact into the performance, and also help to pinpoint the opportunities where to fix that. So now, once your code is instrumented with PS plugin, you've done the automatic instrumentation and you got those traces. You're also once you've instrumented the app, you're all set to record some traces and dive into understanding your code on a whole new level in order to catch the optimization opportunities. And that is actually the sweet and intuitive part of performance analysis. As a user, no matter if you're an engineer or a non-technical stakeholder, you can record a trace file while using the app. Say you're opening a particular page in your app, and the corresponding trace file will contain information about all the code events executing in your app in the meanwhile. Well, actually, only those among those methods that matter. But also, together with the trace file, what you will record, you'll be able to make a screen recording of your phone. And PS2 will automatically synchronize everything that's been happening in your code with what user saw on the video. So here is a sneak peek into that. As said, PS2 will automatically synchronize the video that you have with the code, and it will visualize the data from your trace file, from your code, in a simple and understandable manner, highlighting the execution path. So you see execution path jumping in here as yellow line on the right. And the execution path would be like an automatically built critical path, meaning that once you click on any method, you will see exactly which other method scheduled it, when and from which thread it happened, and see what was the sequence of events. So we see a sequence here leading to the user seeing the response from the app that they expected to see. So you would be able to separate the process that you're analyzing, the process that you want to optimize, not just optimize the whole app in general, but the actual particular piece of user experience, the one that matters. Now, for this demo, before we jump into the tool, for this, I just need to add that for this demo, we'll be using Telegram app, which is one of the most popular messengers around the world. They recently hit 700 million of monthly active users. So I hope that at least some of you are familiar with this app. Another reason why we are using Telegram for the demoing purposes is that it is an open source app with a highly skilled team focused on performance, which is especially important for messengers, of course, because users are constantly interacting in this app and you want to receive your messages faster. You want to, you don't want additional delays being introduced by the app. So for us, it was an interesting task and a particular challenge, given that for this app, low-hanging fruit of performance optimization would be already fixed. So how easy it would be to find something with PS2 there. And now, without further ado, let's jump into the tool. Yep. And here is the first screen that you would see once you've recorded and uploaded a trace file to the PS2. And the first screen would be the annotation screen. That is just the way where you can look into your video, especially if you're a non-technical stakeholder. What you can do is you can see the recording of what was happening in the app. And you can annotate it, annotate user's action, annotate where the annotate user's reaction, app's reaction, where any UI changes appeared, as well as any noticeable delays here. So I'll play a video slower one more time to show you what was happening in the app at this time. And the user flow that we chose for this analysis was the app start, followed by opening of the first page that contains the chats with messages. So the app start is a user flow that's important for all apps. Everybody wants to make it faster, and it's a hard technical issue. And one thing that we always want to point out, that it's not only to the time when the app becomes active, but actually to the point when user sees the desired results, when they start using chats. So that's why, as a reaction here, I've put the place where chats are updated and they start revealing on the screen. So after this annotation part is completed, you can already look into the trace file or send it to your engineering team to investigate further. And here's what you will see on the trace viewing screen. So this is a trace file of your app. You still can see the video. I've slowed it down by 50% just so that it's like slightly easier to follow. You see the app start. You see the area where chats appear. And you can also scroll through the trace file. You will see all the methods, all those methods that matter, executed here on top in the main thread, and also in all the other threads. You see there's a lot of things going on in the app actually while it is launching. And if you click on any method, as I mentioned, you'll see the execution path, you'll see sequence of these connections. You can also zoom in and out to see all the smallest methods running in your code. So that's like the visibility that you are getting. Now, when analyzing the app start, when analyzing the flow that we're looking into, what you can do is you can just click on the reaction, which would be connected to the particular slice that is responsible for updating the UI here. And what you will see would be the execution path, the critical path, the sequence of events that led to this UI update, that led to chats appearing on the screen and revealing here. And what we can do is we can slowly zoom into this path and follow every step of it to understand what's going on. So I'll actually zoom out and we'll see where it started. So it all gets back to the launch activity on create, and we see that something that is leading to loading messages and showing them on the screen is starting during the first frame of the app. So before it was, we just clicked on the icon, and then during the first frame, we started doing something with the messages. And the first methods that I will see here would be dialogues activity checklist load. That would schedule another call, also on the main thread here. That would be message storage get dialogues. Now, this one on its own, and I'm zooming out back to see a fuller picture, would be triggering message storage get dialogues, so loading messages on a parallel thread, which after completion would lead us to message controller process loaded dialogues. That makes sense. You want to get dialogues, then you want to process them, then eventually you would have a bunch of other smaller calls that will end up in put messages and eventually showing those messages, post notification name, showing them in the UI. So once you have this execution path, first thing that you may notice like that, it looks very different. Imagine you were, it looks very different in the sense that you can finally separate the process that you are investigating from the rest happening in your app. And looking into this process, you can evaluate it and you can check whether it is executed in the way you designed it, in the way you expected it to execute, whether it is efficient on its own, as well as you can also detect bottlenecks and queues caused by other processes. Here, you may notice that there are some vertical red stripes. In particular, the largest one would be right over here. And let's see how long it takes. It takes just a bit over 100 milliseconds, about 110. Which is a delay. The reason it is highlighted red is because we have two events that are actually related to the process that are initiating getting the dialogues. But between these two events, nothing related to the process is happening. Something is happening for media controller preload reaction. There is a choreographer, there is something else. There is a queue of unrelated events that do something important for the app. They should be there probably, but they're not related. They're not leading us to the final UI change that we want to see. And then if we zoom out, let's see how much our 100 milliseconds is among the whole wait time. And we see that the whole wait time before dialogues appear is below 1 second. So this delay on its own actually is taking more than 10% of total users' wait time. And if we zoom into this area again, and click on the method that we were investigating here, that was the part, the get dialogues one that schedules loading messages and dialogues, we see that this method takes less than 1 millisecond. It's tiny. It's not on its own. It's not long. It's not causing the wait time on its own. Yeah. And the previous one, the one that scheduled it, the checklist load, was also taking less than 1 millisecond. So you have two very small methods that are not taking any extra time on their own. But the fact that, let me zoom out, show the path again. The fact that one of them reschedules another for the main thread puts the second one in the queue, and the wait time is now unrelated to this process and becomes 100 milliseconds, becomes more than 10% of the wait time. So, just a simple change of not rescheduling this call again and calling get dialogues, not instead of this tiny small lambda over here from the original function, from the original place in the main thread, already was able to reduce Telegram's wait time for Telegram's user by more than 10%. And thinking of like other tools and even investigating it without the execution path, you can see how hard it can be to spot such a small function, to spot something that lasts less than a millisecond. If you have a view like this, if you don't see any execution path, if you don't know which of those functions, which of those methods in different threads are actually involved in the process. So among all of this noise, it would be extremely hard to figure which of the methods is actually impacting the performance. And by looking into execution path and seeing at these delays, as easy as that, you can pinpoint the small but important function that would improve your performance instantly. So with that, let me wrap the demoing part up. And I hope by this moment you are curious and encourage you to dive deeper with us into the capabilities of PS2. Join our future demos and please connect with us on LinkedIn, visit our webpage and send us an email. We can schedule another demo or a trial for your team. Would be super happy to connect. And if there are any questions, I would be also happy to answer them. Okay, so I'm seeing the first question here, whether we use any user data. So not really. We do not collect user data. The traces that it's a great question. So the traces that are recorded by our clients' internal teams that the tool can be used as a pre-production tool. So whenever you, there are a few ways how it can be used. If you already have a degradation, if you already have a delay, slowly opening page, what you can do is you can record traces for it from like the main branch, even from the production version of your app, and you can analyze traces from this. But also, if you're making any changes and you want to see that those changes don't introduce degradation, or if you want to check whether the performance improvement is achieved, you can build the app easily with the same instrumentation and record traces on that version of the app. So any commit, any code fixes, you can capture them on the traces. You can use test environment, or you can use production environment for that. But yeah, these are all traces recorded intentionally to investigate performance. However, if you are collecting users' data on your side, like some performance logs, some performance metrics, one other cool use is to check your performance metrics and to evaluate whether, like, what you are, to compare the code that is injected to collect those logs, and to check whether it's actually representing users' experience, and maybe to improve the data that you collect to track performance by better visibility into like which methods matter. Sometimes you may want to get more logs, or to change the way how you evaluate performance, like on the field data. I hope that answers your questions, Haley. Thanks. Any other questions at this point? If not, I see that we're already 1 minute over. So thanks everybody for joining today, and I'll hope to see you again. Let's connect. Have a great day.